In this video, we will examine the types of basic GNSS spoofing attack scenarios and how they are implemented. Let's begin with the simplest and least expensive, the asynchronous and non-coherent attack. Asynchronous attacks can be accomplished with any commercially available GNSS signal imitator, or with software-defined radios and open-source software from GitHub. An attacker can generate false coordinates or time. However, a non-coherent signal is different from the authentic one in Doppler and pseudo range. Thus, when the receiver is already locked onto the original signals, a non-coherent signal is perceived as noise. To execute an asynchronous attack, an intruder needs to disrupt the genuine signals. This is achieved by broadcasting spoofing signals 40 to 50 decibels higher than the true satellite signals. Doing this forces most receivers into search mode, and thereafter they lock onto the fake signals. Effortless, right? Then again, it's also simple to detect such an attack. A significant increase in signal power or jumps in time and coordinates is an indication of the attack. Synchronous attacks, in contrast, are multifaceted and costlier to execute. As the first step, an attacker generates signals identical to the genuine one in time, coordinates, Doppler, and pseudo range. As a result, instead of losing tracking and switching to search mode as in asynchronous attacks, the receiver switches to the imitation signals with no errors or interruptions of operations. Afterward, the spoofer can smoothly move coordinates, time, or both. This is only one way to detect such an attack, and this by recognizing a distortion of the navigation field or by estimating the angle of arrival of the radio signals. This requires the use of multiple spaced GNSS antennas. Synchronous attacks with multiple transmitters are the most sophisticated and expensive attack scenarios. In this case, an intruder uses several distributed GNSS spoofers with precise synchronization. Each spoofer generates a signal from one or two satellites. It's the most challenging case scenario to detect because signals come from multiple directions, and it is difficult to make a distinction between spoofing and multipath effects. Other types of attacks, such as record and playback and meoconning, transpire. It's simple to record a live signal and replay it or rebroadcast it in real time. Future prospective developments on GNSS signal authentication will not work in that case. Subscribe to our channel to get the latest on GNSS cybersecurity.